Welcome back, friends. So, in this lecture, we shall study Superposition Theorem presented by Hanumanth Shetty, lecturer, Government Polytechnic, Mudol. So, Superposition Theorem states that in any linear circuit containing multiple sources, superposition is mainly for a circuit which have more than one source, voltage or current source. So it says that in any linear circuit containing multiple independent sources, the current or voltage at any point in the network can be calculated as algebraic sum of the voltage or current responses due to each source acting alone, with all other sources replaced by their internal impedances. Meaning to say, in any circuit, if there are more number of sources, you have to keep one source active at a moment and turn off all other sources or replace them by their internal resistances, and you have to calculate what is the voltage or current from this source at a particular point. And then you have to repeat this step for all other sources, and finally you have to calculate algebraic sum of all these results. That is the final voltage or current at any place. Now you can solve a network using you can find out current or voltage at any point in a network using the superposition theorem. Now, let's see how to solve a network using this superposition theorem. Now, steps to solve a network using superposition theorem. So, here, first step is select any one source and short all the voltage sources or open all other current sources if you have. So, you have to keep active one source and you have to replace all other sources by either short circuit if it is for voltage source, and if or open circuit if it is a current source, or replace it with its internal resistance if it has got an internal resistance. Second step is find out current through or voltage across the required element. So where you want to find out what is the voltage or current, you have to find out using either KCL, KVL, Ohm's law, current division, voltage division, etc. You have to find out what is the voltage or current at that point using this single source. Third step is repeat these steps for all other sources. So you have to do this for all other sources in that network, and then in the last step add all these effects produced by individual force acting alone. So you have to add all these results, and that is the total current or voltage at that point. Now let us take an example for this superposition theorem. Before that, let us see what are the limitations of superposition theorem. So we cannot apply this theorem anywhere. So it is applicable only for linear circuits, so which have a linear effects. So in those applications you can apply this superposition theorem, and it involves more work when number of sources increases. So let's say if I have a network consisting of some 5 voltage sources, then more amount of calculation has to be done, and it requires more work. So it has limited for a limited number of sources. Since the power equation is not linear, so power, what we write, P is equal to I square R, or P is equal to V square by R. So where a square function is there, so it is not a linear function, so hence it is not applicable to power calculations. So this point you should remember. So linear, the superposition theorem is applicable for only linear circuits and not for the power calculations. Moving further, so let's study an example using superposition theorem. So in this example, Using the superposition theorem, determine the voltage drop and current across resistor 3.3K as shown in the figure below. So they are asking us to calculate what is the voltage drop and current in this particular branch using superposition theorem. Now, what superposition theorem states? So, it's applicable only for the sources which are where there are many number of sources. So, here we can find out two sources. One is of 8 volt and another is of 5 volt. So, I can easily apply superposition theorem. Now, to apply that, what it says, first you have to put off or replace a source by its internal resistance or short circuit it. So, here I am removing 8 volt power supply. So, I'm removing that 8 volt power supply with a short circuit. Now I have to find out what is the voltage and current through this resistance using this source alone, that is 5 volt alone. So to do that, so how these two resistors are connected, that is 2 kilo ohm and 3.3 kilo ohm resistance are in parallel now, and then this parallel combination is in series with 4.7 k ohm resistance. So now easily you can find out there is total resistance RT is equals R1 into R2 plus R1 plus R2 since those two are parallel. So 2K into 3.3K divided by 2K plus 3.3K is equal to 1.245K. And this 1.245K is in series with resistance 4.7K. Now we need to find out what is the voltage in this that is 3.3 k ohm resistance. How can we find out that? So using voltage division rule. So what voltage division rule says? Supply voltage into the resistance at which you want to find out voltage divided by total resistance. So here at 1.245 k I want to find out voltage drop. So I will write 1.245 k into 5, that is voltage supply voltage, divided by 1.245 k plus 4.7 k, which is equal to 1.047 volt. So that is the voltage at resistance R3, sorry, 3.3 kilo ohm resistance. Now next step is to you can put off this other source, that is 5 volt supply, and then follow the similar steps. So here I am turning off the 5 volt supply, and that source is replaced by a short circuit. Now 3.3 kilo ohm and 4.7 kilo ohm, which both are in parallel. So hence I can write R total is equals R1 into R2 divided by R1 plus R2, that is 4.7K into 3.3K 4.7K plus 3.3K, which is equal to 1.938K. Now I need to find out what is the voltage at this resistance. So V2 is equals 1.938K into 8. 8 is the supply voltage divided by 1.93K plus 2K. So that is equal to 3.9377 volts. So now we have got two voltages. One because of voltage source 1, that is 5 volt. Because of 5 volt I got one result, that is V1 1.047, and because of 8 volt I got one more voltage supply, that is 3.977. So finally what we can do, according to superposition, we can add these two. V total is equal to V1 plus V2, that is 1.047 plus 3.9377. So finally V total equal to 4.9847. That is this is the amount of voltage that is applied across 3.3 k resistor. So like this you can solve any voltage or current at any place using this superposition theorem. Thank you.